This is going to be securing the supply chain. It's not necessarily going to be anything to do with traditional supply chains at all. But yeah, a little bit about me. I'm previously a database administrator, previously a Linux administrator of hundreds of machines, previously a systems engineer, and then I had done almost everything on ops except I'd always been adjacent to security, doing a lot of security, so then I moved into security full-time, going to Scurry, which just so happened to be adjacent to the supply chain. So this is going to be more about the digital supply chain and how we trust and how we build projects. So this traditional supply chain is all about how we get really raw materials, create a product with them, and how we get them to the end user. It's a big, massive chain. It's a very, very complex environment. There's a lot of moving parts in it, and there's a lot of trust that goes on. How does that relate to the digital supply chain? Much like this image, that's a bit of a mess at the minute. How do we trust where things come from? How do we trust them in our product? And all the steps along the way to how do we get there. So in security, we have something called the CIA triad: confidentiality, integrity, and availability. Any breakdown of one of three of these is a breakdown in your supply chain. So we've got a very toy product to walk through the whole demo with. We'll just use an example. So if you're building a very small, even very small Python application, you're scripting nowadays, you're well aware how many libraries you're importing and how many packages you're using. And you're just running pip installer requirements on a file. These are all part of your supply chain. They're supplying you with software, you're including it in your software, and you're shipping it off to customers. So all of these are part of your supply chain. If you're then hosting that code on a cloud, that cloud infrastructure is part of your supply chain. It's especially important with the shared responsibility model. You've got a lot of code running up there. You have a responsibility a lot of the time to secure your systems as well. And then inside of that system, you've probably got kernel code. You've got operating system tooling that's running alongside your code. Again, as a developer, traditionally, you probably don't really care. You care about the code that you're writing, not the code next to it. But again, when we're talking about a supply chain and a package going to a consumer or a customer, all of this tooling comes into play. Your APIs that you call, external dependencies. If you're a wrapper around OpenAI and you're shipping it as your product, OpenAI is now your biggest supply chain risk. They changed their pricing to make it unsustainable for your product anymore. They cut you off because you were breaching some weird terms of service. It's a supply chain risk. It's a supply chain aspect. And then if you outsource your identity and your single sign-on capabilities, again, they have an outage. They're affecting your availability. It's all part of the ecosystem that is the supply chain of getting code to customers. And then developers, editors. One of the most overly looked aspects of the supply chain is what is the code being written on? What is injecting code alongside your developer, say Copilot? All of these are part of the broader ecosystem of how do we trust code along the way to the consumer. So now that we've got kind of that overview of what the digital supply chain is, we're going to look at some problems. As I say, developers love installing things. There are hundreds of malicious VS Code extensions created to look exactly like productivity tools, exactly like tools that will really help you. Sometimes they help you, sometimes they flat out don't work, but they can often sit next to your editor and steal credentials, steal API tokens, and then feed them all back to whatever cloud server that attacker wants. Developers they're harder to catch with phishing. Now, developers still get caught with phishing. Ask me how I know. But oftentimes, if you just reframe that malicious package into, say, productivity software, they're still clicking a link, they're still handing over credentials, they're still installing things. It's just a different attack model. The XZ-utils, many of you might have heard this story, but over the course of 2 years, a threat actor gained trust with the XZ-utils package, slowly adding commits, slowly working their way up to maintainer, and then committed a binary that was a backdoor shell into the XZ-utils. Now it was caught, but it raised a lot of questions of the open source community, the immense pressures that they're on. They're often volunteers, and then now they're having to review not only for code quality, but if the code is malicious or not. And it would really shook up a lot of security people that I was talking to into that XZ-utils is so out of everyone's radar, but is included on almost every Linux distribution that it got a lot of people thinking, how much is out there? Has anyone done research on how much is out there? Has anyone done research on how easy it is to get malicious code into the Linux kernel? They have, and the community did not take it nicely. This was 3 years previous, so I mentioned it was the XZ-utils was caught in 24, took 2 years, so they started about 2022. This research came out in 2021. A group of university students were, and their supervisor was orchestrating it. They were trying to come up with a way to automatically find malicious bugs. They had submitted 278 patches, 151 were accepted as good patches, and then they came up with a brand new idea for a paper. Can we inject a known, what they called it, a hypocrite commit? It was malicious code that they were trying to sneak in to the Linux kernel. And it managed to pass. It got in, they brought out this paper, and the community had huge backlash. You were trying to test this on unpaid volunteers, trying to get things in. Nobody took it well, and the university itself got itself banned. But it did bring up the question of we've got to kind of have a bit of awareness about the supply chain, how these things get in, and who can commit to a project. A little aside, credential stuffing is one of them things that you see, you understand, but it's really until you understand the grasp of how much credential stuffing is out there. Verizon release a report, and I know this is kind of small. They release a report every year of an investigation of data breaches that they see actively happening. If you see credentials are the #1 way by far in. And credential stuffing is just taking username and passwords from previous breaches that have been leaked on the internet, finding somewhere else to put them in and shoving them in. Does that username and password work on this different service? And trying loads and loads of different services just to see what they have access to. And it absolutely works, hands down. So far, like you can see the top 3 there are credentials being stuffed into web applications, phishing, and exploit vulnerability. And what has security professionals been saying for so long is just change your password, manage your credentials well, don't click on links, and patch your systems. That will get you so far. That's the 80 or 90% of the easy stuff that you can do to protect systems. But what happens when we don't protect these systems and credentials get stuffed? We have to snap enable 2FA, and PyPy would have done this because they would have seen so many credentials being stuffed into PyPy, packages being taken over, and then exfiltrations happening, because if you can take over a package, you've got remote code execution on a lot of places. So that would have been a great thing for the community. I know a lot of people say to me they hate 2FA, but for this sort of stuff, it really works. I have seen so many investigations, even in my own work, where 2FA has just caught it. It really is sometimes adds a bit of friction to the experience, but here it really protected a lot of packages been taken over. And then what happens when you can't just take over packages? Just create a free account yourself. PyPy was seeing so many user registrations signing up and creating typo squatting. And again, if you look up typo squatting around PyPy specifically and bug bounties, A lot of people got remote code execution on Fang, PayPal, just by typo squatting a package that maybe was the NPM name for that service. People put it in to, people just pip install, guess the name, and if it installs, that was probably correct. But a lot of the time there's typo squatting of packages, or they will like name it like Python 3, the name of the package, or maybe it was called Python 3, the name of the package, and they'll just name it the name of the package. So like it's just very easy, sorry. And especially if you have an internal repository, software repository, and that package doesn't exist, there have been source code leaks where they can see your imports, they can see that that package doesn't exist, and then hopefully trick developers into installing it, not from your repository, but from the main pip repository. This is a Docker Hub image I created when I was a student. It never worked. It doesn't even run. But people, for some reason, came across it, and 340 people thought they'd take it for a whirl. They have no idea what it does. There was no, as I say, the Docker file didn't even work, but 340 people took it for a spin. I don't know why. They have no idea what's in it. So a lot of the time, it's not, as a security engineer, a lot of people come to me to see if they can do something. A lot of the time, I want to say no, it's my first instance, but you also can't be the department of no, otherwise people work around you, not with you. So it's often, how can we come up with techniques to mitigate the risk of this happening without just saying, you can't do this. Developers still need to write code. They still need packages, but how can we add a little bit more trust to them packages? So like, it should add a bit of a degree of freedom to the developer. Your R&D department, what do they need access to? Do they need to research this? How, like, mitigations we can do. This is a real incident that we would have had internally. This is Windows Defender, which has come a long way in recent times, but it alerted to a file and quarantined it, and it was only a text file, and it was something our R&D were researching. And it was just a data set. So why was Defender going off? I blame Defender for being too overly permissive, but it was worth the check anyway. And sure enough, it lights up in VirusTotal. If you look at the behaviors of it, and if you look at the matching rules, this really was indicating that it was something malicious and warranted further investigation. And this is what it was showing up as. It was showing up as a malicious Trojan that was in there. So it was definitely worth a look. But it's a data set. It's just a bunch of garbled text. But this, again, was a data set to train some machine learning by the R&D department. Here it says, I know you probably can't read it, we want to find out the purposes of the following script. Add some useful comments to it. The Trojan. Absolutely just pasted in there. Why would someone give out a data set that has a Trojan in it? This was for other people to use. And again, it's a data set. No one executes a text file. How was this ever going to compromise anyone? So we were looking at where the data came from. How did this Trojan make its way into the data set? And you can see the data set is collected from their website. So the background to this is this research group just posted on the internet. You put in a query, and it would query 2 different models, and then you would vote which one was best. But this is open access to the internet, so anyone just could go in, and someone has injected this Trojan in to see if it could get the model to explain it, maybe to train it, to modify it, obfuscate this script a little bit. So there's many reasons why, like, the origin of the data set matters, that if we had just taken this and trained on it, shipped it to production, would this recreate this Trojan if someone asked it? This Trojan's probably not very good to have. It was probably maybe safe, but also maybe not. So I went looking to see if there are many instances of this, but also Defender and other malware don't really care how much malware is in there. They stop at the first one, usually. How much other malware was in there? How many other Trojans, scripts that we were training on? As I said, the training set was huge. To go through and clean it all would take a very long time. But it is a massive thing. Again, when you have a repository and you have people showing up, there are many malicious data sets out there. This person obviously had backdoors, and that code did run and managed to run on the machine. So it's all about just knowing where the data came from, what the origins of something is before you run it, and just having them endpoint protections in place that if something does run, you can kind of catch it. Again, it's not saying there's no R&D to be done, there's no data sets to be downloaded. It's just having them extra steps in place to kind of catch these when they happen. So then we'll kind of talk about some solutions. I have no solutions. There's no silver bullet. I have strategies to work towards solutions that suit you. Big companies don't really care for a lot of risk. Their risk appetite is low. They have a massive business to protect. They have a massive reputation to protect. If one person brings down the company, that's an issue with security. If you're a startup, if you don't move fast enough, you're going to die anyway. So just go hell for leather. Who cares? We'll try our best to add security in, but that's generally the model startups work with, is move fast and figure things out on the fly. So that's all about like risk appetite and how much risk you can tolerate. So as I say, it's risk reduction. How can we add protocols in to reduce this risk? So here's the diagram from earlier. What protections can we kind of add in place? Well, a lot of the times nowadays, there's going to be firewalls in there. You can see data moving in and out of your network. You can catch a lot of IOCs, like indicators of compromise there, a lot of threat intelligence you can gather, and you can just kind of monitor and see and catch things early. It's pretty good. A lot of data loss prevention systems nowadays are pretty good. Your external entities, like APIs and your SSOs, you can't really manage the risk of what they're doing, but to the best of your ability, you will offset your risk by having contracts and making sure there's really good SLAs there. And you're managing risk, you're offsetting risk that way, that you're trusting them companies, you have an agreement in place. And then I talked about your endpoint detection. Install it everywhere you run code. You want that to be able to catch things before you ship software. But the endpoint was also part of the supply chain, and now it has killed everywhere you run code. So what strategy could we have done there? Well, CrowdStrike do have a system where you can do an N-1. You can do maybe not the bleeding edge update. Now, you're offsetting risk because they're a threat intelligence company. They're saying, we're seeing this, we're pushing out threat intelligence. So it's a trade-off there. But if you want a really resilient system, maybe that N-1 might work for you. If it's a package, maybe N-1 that package as you're going through. Now, these are feature updates, not security updates. Do your security updates. But then it's knowing your update. And that brings it on. Know your update. Why are we updating? What are the new things coming in? And can we trust that? Is that coming from where we think it's coming from? And there are kind of 3 PEPs that I'm aware of and have been following. And then there's kind of a new one, PEP 740. It's still provisional, but it's quite easy to use. The top 360 packages, 21 are currently using it. And its whole purpose is to just provide an attestation. So you've got your traditional attestations, kind of like your checksum with a SHA-256. Does this package match this package? But then you've also got a, does this come from where I think it's coming from? So you're attesting that this is coming from a particular GitHub repo, from a particular GitHub user. And sorry, they're pretty easy to use as well. Say if you're using GitHub, you can set up GitHub Actions, as long as you're using a trusted publisher. I know in PyPy, if you go in, you can set up a trusted publisher, and then with GitHub Actions, you set it up once, and then from GitHub, you're just automatically deploying to PyPy with that trusted attestation. Again, this is 21 packages. This only became accepted PEP in July, I'm pretty sure, I think. So 21 might not seem a lot, but it is still pretty new. And again, all the gray bits on the wheel are packages that have not been updated since then, so could not be aligned to PEP 740. Another strategy that a lot of companies use is an internal software repository. So you're adding that extra step. You're bringing packages in, you're checking them, they're known good versions. It's one of the ways to technically implement the N-1 that your security team is bringing in, verifying. Because again, with the whole attestation and trust, how often does the average developer check the SHA-SUM to make sure it came where it came from? It hasn't been malicious. A lot of people are just moving too quick. So if you're implementing a software repository, your security team can automate that, do that, check your packages for you. The one thing I see a lot of companies make the mistake of is if your product in production is using that software repository, also make sure your developers are. They're not installing software just purely from pip, and then that adds sometimes a lot of friction between packages differing. Just make sure your developers can only pull from that internal software repository. Code minimization. I know this is sometimes hard, but it's evaluating your packages before importing them. How much code is in this package? How much code am I using out of this package? There's a very good correlation between lines of code and bugs in code. More lines, more bugs. If you can at all, it's walking through and seeing what do I really need in that package. Can I maybe write the 3 lines, 10 lines that I'm using out of that package and just write it into my own project? A lot of companies are doing static analytics now in your CI/CD pipeline. There's a lot of cool tools out there, maybe some semgrep, your sneaks. They're analyzing your code for vulnerabilities. Maybe in that pipeline, when you've downloaded the package, maybe include some of your dependencies and libraries in it too. Best case, you can submit a bug report and be part of the community. Consider paying for the code you use. Now, I don't mean necessarily you, but maybe making a case to support open source projects. A lot of these people are volunteers. Again, a lot of times if you're submitting a bug report to them, that's a security issue, give them the time. I know it seems really scary, but it's working with them and giving people time to patch and update and getting that out to the end users first. It's just make sure you're responsible for that disclosure. Now, I know submitting to bigger companies, a lot of people like mandate the 30 days, 60 days, 90 days. Maybe have some sympathy on the open source community. Make sure they're listening to you and work with them. If you can write code and you're a security engineer, you find it, maybe help them out with a PR, point them in the right directions, or just give them details of how you found it. And again, it's just coming back to that risk management. It's not the Department of No, it's not don't use any packages, it's just the intentional use of packages, knowing your updates, knowing what you're doing, and then figuring out that risk level. You'll never get the risk to 0, or you'll never write code, and maybe just find where you're writing code for, get that risk appetite, and then achieve that risk to the best of your ability. So I think I'm just up on time, I think. So perfect.